everyone. My name is Will. And today we are going to share our experiment of building our own endpoint, and that is integrate OAI as a service into the endpoint. So first of all, let me introduce our team to you. Actually, we are just 6 people, and we are come from an industrial technology research institute and in National Jiao Tong University. And we just started this program 4 months ago. And just last week, we finished our end-to-end test about the Encore 4.1 version. So first, I will introduce a little bit about the open air interface and our objective and our demo scenario. Then I will talk more about how we implement our OAI-as-a-Service in the Encore. And finally, I will talk about a little bit our future work. So, OAI, since today, we have a fully open source EPC and ENOV. This program is this is a Eurocom program, and its fully name is Open Air Interface. And actually, it has support the whole LTE network architecture from the UE to ENOV to EPC, and you can just use normal x86 machine and build your own LTE infrastructure. But about the UE and the ENOV, you should use the additional radio-defined, software-defined radio to have the availability to wireless communication.
Which SDR are you using? Are you using any one specific SDR?
Yes. We use
Micro or?
We use this one, X310, as our SDR. Because it's more powerful, its performance is better, and it supports the PCIe interface and the optical interface. And for now, we use PCIe interface. But for future work, when we build a core part, we will use optical interface. And OAI EPC, it has a MME, HSS, and S gateway and P gateway implementation, and it is compatible with the 3GPP release 10. Yeah, and it supports some UE procedure like attach, authentication, service access, and radio bearer. And this configurable APN and the IP range and the DNS, and it supports IPv4 and IPv6. Okay. So this is the original OAI LTE EPC software stack. You can see that it put these three major components together. That include the MME application and the SP gateway application and the HSS database. But in our case, we separate it into 3 components, and we will talk about that later. So, what?
Are these running on a bare metal, or you're having on a container or VM? How are you? Those components you're showing, are they just running on an x86 directly?
You mean EPC part or ENOV?
The EPC part.
EPC part is we use the begin and running on the port.
It's a VM?
Yeah.
Okay.
So, why we want to try this, because we are very interested in the mobile network, and we think Core is the best platform to run the virtualized mobile network. And what we are trying to do is to verify the service function chain in the Core. Yeah. Okay. So first we build a M-Core in the box 4.1 for the first prototype version. And we use OAI-EPC as our M-Core service. And for the service function training verifying, so we divide OAI-EPC into MME, HSS, and the XPGW. And we just finished our end-to-end integration test last week. And we have a live demo outside. So for our demo, we can use commercial UE and OAI InnoB. This OAI InnoB is just built on the x86 PC. And the EPC part is in the calling box. And we can easily use the UE to attach to the EPC and go through the internet. And for now, our performance about the latency, the UE to the SP gateway is about 22 milliseconds, and the bandwidth is about 4 megabit per second. And it is because of the InnoB part, because InnoB is need more powerful to do some
acceleration.
Yeah.
So if you had a NIC card from, let's say, FPGA NIC card, you could accelerate a lot of your file functions on FPGA.
Yes. Because we don't have that resource. Okay. So, so the next part, it will more like a tutorial about how we implement our OAI M-Core. So you have a lot of detail inside. So for the first prototype, we are focusing on the virtualized EPC service, and for the future work, we will do some mobile edge service. This is just showing the service dependence. So InnoB is out of the coin box server. It is a independent PC, and this one is in the coin box. So when you want to onboard your own service, you have to. This is the first step you need to do. You need to create your synchronizer, and to do that, you need to access into the codec begin and write your own source code. And when you build the XOS, you will build into the service synchronizer image in the local image, and then it will be pushed to the head node and in the Docker registry, and then it will be pulled and run as the OAI service synchronizer.
So I'm sorry, go back. So you're saying that your image, that source code is basically, or you compile, you build it into and create the image and then you push the image. Okay, got it.
Yeah. Okay. And after you have your own service synchronizer, you can write your OAI postcard YAML file, and XOS will and you can use postcard API to push this file to the XOS, and then they will have two work to be done. For the OpenStack, it will tell OpenStack synchronizer, and the synchronizer will tell OpenStack component to create three VM, and then OAI service synchronizer will wait until this 3 VM is built up successfully. And when it is successfully built up, the OAI service synchronizer, we tell them to load 3 different images, and then they will become 3 different instances, like this HLS and MED and SPGW. Yeah. And if you want to do this, layer have a little trick in there. This is a normal procedure. You need to build an Ubuntu VM. It is for the OAI PC, right? And second, you need to install OpenStack image tool called Cloud Init. This is for the OpenStack. OpenStack will read the metadata and put the public key for the synchronizer, because the synchronizer will access into a VM, right? So this tool will help us to put the public key inside it. And then you install whatever you need. For us, we install our OAI-PC. Yeah. And then this is the most important step. You need to use this virtual system preparation, this tool. It will clean up all the configure. This configure is, when you first build your VM, it will have some network configuration or SSH configuration. And this is the old configuration. And when you use OpenStack to bring the VM up, the OpenStack will try to add more network configuration into it because OpenStack will need more network interface, right? But if you didn't clean up the old network configuration, you will have some conflict. Yeah. Then you should use this to convert the image format and compress the image.
Just a comment here. When you are talking about OpenStack VM image, you can just find there's a cloud image released for OpenStack. For example, you want to which version 92 or which stable release, just pull it, convert from Qcloud 2 into VMDK, make some changes and convert back to Qcloud 2. That's it. You don't need to follow this.
So you say
just a cloud image. Just find the OpenStack Qcloud cloud image. Or you want to solution. And that's all our other VMs. Other release distros will have the similar cloud image.
And you say download it and we can convert it to
from the Qcloud 2 format into VMDK.
And we can
then you can load it in VM in VirtualBox or anything, and then make changes there. And then put it back. It will keep Qcloud.
Okay, thank you. We will try that. So after you successfully bring up your VM and put your image into the VM and so they will become the 3 different instances. Then they have some more work to do. That work is related to the service synchronizer. This is the service synchronizer procedure. Actually, there are 3 steps need to be done. The first one is to the synchronizer, it will always wait for the dependent instance IP address to be ready. It is because in the EPC, the component will need for example, the MEV component will need HSS IP and the SP gateway IP. So the synchronizer will always wait for the instance IP to be ready. And when it's ready, it will prepare the service-related configuration. That includes the IP address and the EPC component of what EPC component needs. Something like APN or the MCC, something like that. Yeah. And then it will tell the Ansible playbook to create this configuration file and the data, and put the file into the instance. Then the Ansible will enable the OAI as a system MD service. So, as I say, for the HSS and the SP gateway, they only need to depend on their own IP. And for the MME, it will depend on HSS IP and the SP gateway IP and its own IP. So the synchronizer will only execute when the dependent instance is ready. So how do we get the IP variable? The instance will wait. It will listen to the VN's port, and until it get the IP, the synchronizer will get that IP and then render the IP variable into the Ansible playbook. So this is just a simple code. Okay. So now we get the IP, but there still have some data that the instance will need. Like HSS, it will need sync data, and the MME will need MCC and NNC data, and SPGW will need APN data. And all this data is first install in the data model, and then we'll load into the synchronizer, the corresponding synchronizer. And this synchronizer will help and will install it, inject this into the Ansible playbook. And this is all the configuration file that OAI EPC need. Like the HS configure, and this one HSFD configure is for the authentication, and HS will need the OAI SQL file. Okay, so this is the whole picture about all the data model and the synchronizer step and how they go through and go into the different instance. Yeah. And just for the MAE, we will need more information like HSIP and SPGWIP. And after you configure your instance successfully, then the Ansible will need to generate a system MD service. And this system MD service will reference into the OAI program. And after that, Ansible can create that VM into different EPC component. Yeah, you can start to become like MME service or the HSS service. Okay, so now your VM is successfully become a EPC component instance, but for the networking, because we use the calling box, right? So there have some work, some more work need to be done because it is not like the core part. Yeah. So for the connection from the InnoB to the instance, go in the EPC, it is no problem because the traffic from the InnoB will go through this port. This physical server port is bridged to the underlay OBS, and this underlay OBS is simulate the underlay fabric. And actually, this underlay OBS cannot be controlled by the fabric application because it's just a bridge. But all the traffic goes through here into the OBS, underlay OBS. It will go through this line to this fabric interface, this overlay OBS fabric interface, and then it can look up the destination IP to, and you will know this packet its destination is which port. And for the all instance, it will have three network. The first one is private network, and the second one is public network, and the third one is management network. And for the combination for InnoB and these three components communication, they all use the private network, and for the public network, it's only used by the SP gateway because you need to go to the internet. And for the management, it's used by the synchronizer and the OpenStack.
Question, sorry. The InnoB OpenAI interface as InnoB is only recognizing the EPC HSL plus EPC as IP.
Yes.
So how did you foresee like 10.0.14.2, 3, 4? Foresee the IP assignment in InnoB because you are uploading the InnoB, EPC IP there, right? So you want to make sure that it's coming up with the same IP.
Yeah. Actually, they are in the same lane.
Yeah, I know. Going to overlay or underlay is no problem, but essentially InnoB is recognizing those EPC components as IPs, and it doesn't go by host or doesn't go by any other thing, right? So,
This is on core 4.0.
4.1.
And it goes out to the internet, that SP gateway?
Yes, go to the internet.
what configuration did you have to do for that?
For that,
Nothing?
we will.
Okay.
Okay. Oh, I forgot to say. Okay. So, as I mentioned, go into the EPC will be no problem, but for the EPC part, if they want to go through to the InnoB, they will have one problem because for the coin box, our InnoB is not inside the coin box, so the destination IP, this InnoB's destination IP, what to say, overlay OBS cannot know the InnoB destination IP, so we have to manually add one raw entry inside this overlay OBS. Tell this OBS if the destination IP is this InnoB, you should just send the packet to the framing port. It will go out. Yeah.
One question. So, can you please explain what is the difference between underlay OBS and overlay OBS? And
Okay. And that is because the core architecture.
Yeah, so the underlay is the class architecture when it does automatic load balancing, and then overlay you basically assume that the fabric exists in the underlay, and then you build on the VXLAN is used to create your overlay on top of it. But when we have this spine and leaf connectivity, you have to establish the underlay first.
right.
That's part of the, I guess, I'm not sure what Saurabh has been calling it, but typically that's what they call it. So in other words, underlay is like a connectivity that already exists, all the path already exists.
Oh, as I mentioned, OAI service network is the private network is used by the OAI service network. They are communicated with network, and the public is only used by SP gateway. Okay. So for the SP gateway to go to the Ethernet, as we check, so send out to the so if the destination IP is to go to the internet, this overlay OBS will automatically to send this packet to this private port, and this private port will send the packet to this underlay OBS, but it will have a strange behavior because it will send this packet to the head node first, and then send back to the underlay OBS. And we are not sure, but we guess it is because in the coding box, the head node is should be the only one who has the availability to go to the internet. So all the packet it wants to go to the internet should go through this interface, and then overlay OBS. This OBS get the packet from this interface will send to this virtual bridge, and then you can go to the internet. Do you have a question?
So all traffic going out has to go through head node is what you're saying?
This is we observe.
Okay. Okay.
But you can have DVR or virtual router. Okay. Still on course.
Okay. But this is because we use coin box right now. Okay. So for the future work, first of all, we should migrate our OAI service to a core part. And it is because it will have higher performance and scalable, and we can have a physical data plane. And maybe in some update, we can bring our OAI and go to the core. Yeah. And how to migrate? First of all, of course, we need to build the core part. And I think core part in the 4.1 version is more easier to build, I think. Yeah, because we have built core part in version 2. It's a lot of power.
So tricky.
Yes. Okay. So, and the next thing we need to do is to create a corresponding service for the EPC component, because for now we only have one service that is called OAI EPC service, and this service, it controls 3 different instance components. Right? So, for the real code security, we need to separate these 3 into a different service, and then we can do the service isolation, and it will be more easier to be managed. And then we will try to do some network slicing. Yeah. And the last thing we want to do is the real automation. Okay. So, you have any question?
So you said you're going to put the XRAN on your list of next steps, maybe?
Because we have another plan. That is, we want to implement the ETSI's their NEC API framework in our endpoint, and that framework have a lot of you need to communicate with the INOP, right? Just you need to get many information from INOP. And yesterday we find out that XRAN have gathered many information from INOP. So maybe we can just work with the XRAN, then we can get our information and to get some mobile edge computing.
How does Navid helping you guys out? Is he overseeing this project with you?
Who?
Navid, OAI, Navid? Is it Navid? I guess the guy who, you have this picture on top.
Yes, we didn't talk, we didn't have discussion with him about the XRAN part. Yeah, we just use for now we just use OAI. But we knew him.
So is it,
Very good.
is it integrated as part of ENCODE and it's like released or something?
Right now it is not part of ENCODE, but we have talked to the Kingpin, but not August. Kingpin said, of course we can put it into the ENCODE.
So I mean, are there any timelines by when is it going to happen?
I'm not sure. Okay.
Are the slides available? You can share the slides.
It is already on the portal. Okay. So thank you.
Thank you.